All right, chapter 4 is where we finally get into studying a topic that is very specific to chemistry. For the most part, chapters 1, 2, and 3 were general topics about science and chemistry in general, but they could be applied to all other science courses or the scientific understanding. It could be applied to a physical science curriculum, or the understanding of matter could be applied to a middle school curriculum. The scientific method can be applied to a physics curriculum, all of that. But atomic structure is the chapter 4 that we're talking about. And this is where we're going to describe the development of the atomic model. And it's going to guide the students to discover why the model had to be changed. And it's going to give you the historical study and emphasis of the model-making nature of science. Essentially, I feel like a really good way to understand something is to understand how we got here from where it began. And so I think that section A starts off with the Greek philosopher Democritus and goes all the way through Dalton's model and then Thomson's model and Rutherford's model, and talking about the plum pudding in Thomson's model, and going all the way to Chadwick's idea of neutrons and spectroscopy, and then going to Bohr's model. And so what we're doing is we're describing the elements and how they kind of came about, or describing not the elements but the different parts of an element and how they came about. So we're talking about neutrons, electrons, protons, and how we were able to kind of figure out how it's all put together in a model. Let's see, we're going to also explain the ideas behind the quantum model. So the one that we finally arrived at, and this is the current working model, which is, I can't say 100% is the correct model, because like I said, I feel like only God knows the actual correct model. I can only say that what we understand now is exactly that. It's what we understand now, and in 10 years, 20 years, when you folks grow up and become scientists, the ideas, the theories might change. And if that happens, then that will be the more accurate model. And I hate to say it, but even then you won't get the correct model. You'll just have a probably more accurate model than what we have now, than the understanding that we have now. So this material is kind of difficult because we're dealing with things of an abstract nature. I want you to really understand the filling order of electron configuration and how to assign quantum numbers and those kinds of things, and really just try to absorb as much as you can from the history of this thing. And then in section 4C, we're going to cover one of the most important materials in this chapter, and we're going to be repeatedly using this, and that's where we're going to be talking about element notation. So let's see. Section A was talking about how we got to quantum mechanics, and then section B is talking about actual quantum mechanics. And you're going to be dealing with a whole lot of these little pictures like this, and it's probably going to be a little bit, I don't want to say pie in the sky, and what that kind of means is like, I don't really understand where this kind of comes from. I feel like maybe what we'll do is we'll introduce this to you, and as we go further along this thing, you'll see it come up again, and then you'll be able to say, oh, I kind of understand what he was talking to me 2 chapters ago about this thing. So do your best to kind of hang out with this and follow along. And I'll be honest with you, we explained this, a lot of this stuff is going to be us just telling you how it is, because the underlying mathematics of this really comes from quantum mechanics. And I almost feel like as a physicist, I studied physics at Berkeley. I went into my senior year of quantum mechanics, and I really sat down with the book, and I was doing quantum mechanics in physics courses like Physics 400, quantum mechanics for seniors. And when I looked at this, I said, oh, now I understand what I learned 2 years ago in basic chemistry. So some of the stuff that we're going to be explaining to you is kind of be like, well, why did we do that? And I hate to say it, but you just kind of do. And if you really want me to explain it to you, you're going to have to hang out with me for the next 7 years so I can explain advanced calculus to you, so that way you can have the foundation to get quantum mechanics later on. So for now, just kind of accept what they're doing. And then we talk about useful notation and how everything is organized. And we're going to talk about some dot structure. Yeah, electron dot notation, that's really good. And we're talking about ionizing atoms. All right, well, that's what chapter 4 is all about. And again, we also don't have a formal lab write-up for this particular chapter.